This is a project for concrete technology and my name is Manito. As engineers, we need to collaborate and discuss about challenges that we have to overcome in a given period of time. And today we are dealing with the casting of concrete. Well, concrete is a mixture of cement, water and aggregates. Aggregates, namely sand and stones. The types of sand such as slag sand, M sand and river sand was to be used in different groups. M sand was used in our group. We collected the sand, concrete as well as the cement and measured their amounts to keep the accuracy level of good mixture. The cement and the aggregates were mixed together in the working place. Before water was added to the mixture, the cement and the aggregates were mixed for a long time. And this was to ensure that we produced the best concrete ever. And later on, water was added to the well-mixed mixture of cement and aggregate. After adding water, the mixing process had to be fast because concrete hardens and gains strength as it hydrates. The hydration process continues over a long period of time and it happens rapidly at first and slows down as time goes by. To measure the ultimate strength of concrete will require a wait of several years, maybe decades. Since several years was impractical, a time of 28 days was selected by specification writing authorities as the age that all concrete should be tested. As you can see in this video that the concrete is getting more difficult to mix. This is caused by hydration. Hydration is the process whereby water escapes from the concrete or evaporates from the concrete, which makes it more to be hardened. As soon as the concrete gets more difficult to work with, it's a sign that it's hardening. And if it's hardening, more water will be needed, and if you add water, then the accuracy of the project will then fade away. A few moments later, we were done mixing and halfway to the end of the project. And we had to do a slump test. A slump is a measurement of concrete's workability or fluidity. It's an indirect measurement of concrete consistency or stiffness, meaning it is an indirect way of checking that the correct amount of water has been added to the mixture or not, since consistency refers to the ease with which concrete flows. Consistency affects the workability of concrete, meaning that wetter mixes are more workable than dry mixes. The way the slump test was carried out. The slump test was carried out using a conical fresh stream known as a slump cone that is opened at both ends with an internal diameter of 100 mm at the top end of 200 mm with the height of 300 mm. The cone was placed on a hard non-absorbent surface, and this surface keeps the cone level. We filled the cone with fresh concrete in 3 stages. Each time each layer was tempted 25 times with a 600 mm long bullet nose metal rod with diameter 16 mm. After each and every stage, the layers were tempted 25 times, and we did this somehow slowly so that we don't lose count. Tempting was also the important part of the project. However, Group A did it inappropriately. And this will lead to inaccurate results at the end of the project. In Group 7, tempting was done immediately after each and every layer. During the last layer, we had a high inaccuracy of concrete and we had to slide the metal rod so that the inaccuracy can be reduced with the aim of improving the results of the project. The end of the test stage, the concrete was struck off flush with the top of the mold. The mold was carefully lifted vertically upwards with motion so as not to disturb the concrete cone. The concrete subsided, and this subsidence is termed slump and is measured to the nearest 5 mm if the slump is less than 100 mm, and is measured to the nearest 10 mm if the slump is greater than 100 mm. The slump test is suitable for slumps of mediums to high workability. Slump is the range of 5 to 260 mm. The test fails to determine the difference in workability in stiff mixes which have 0 slumps or for wet mixes that give a clap sound. However, Group 8's concrete didn't subside properly. This was caused by not handling the slump cone properly. The mold was not carefully lifted vertical upwards with motion so as not to disturb the concrete cone. The concrete cone was perfectly disturbed. That's why this happened. And Group 5 also experienced the same thing. But the reason why the concrete didn't subside is because Group 5 didn't temp up to 25 times and they didn't temp properly. In Group 7 we had outstanding results, meaning that the slump test was successful and it was measured appropriately. Immediately after the slump test, we discussed about tapping the non-absorbent board so that the concrete could sag and we would place it in the pouring cubes. During the project, there were 3 pouring cubes. The pouring cubes were filled with concrete and they were numbered from 1 to 3 and the group number, which is group number 7. And the reason for this is for them to be identified in terms of loss if maybe something happens. This is mostly done in engineering to identify objects or to identify components. The curing cubes were left in the lab for 2 weeks to let the concrete harden, which is more important for this project. 2 weeks later, all the concrete that was placed in the pouring cubes hardened and formed the shape of the pouring cubes, which is in cubes. And these pictures show the shape of the concrete that has hardened for 2 weeks. 2 weeks. Not less than 2 weeks, not more than 2 weeks, only 2 weeks. And these are the shapes formed from curing cubes.
So like if you act like this, if it's not smooth and the machine just breaks a piece of cement, it will stop. Cubes. I think they've been using all of this.
And those were the readings of the strength of the hardened concrete. Fresh properties of concrete. The first one is segregation. Segregation is separation of coarse aggregate from concrete mass, and it is affected by the amount of void. The second one is bleeding.